Okay, in today's lesson, we're going to take a look at finding zeros of polynomials. So the first thing we need to understand is that the number of real zeros theorem essentially just says that we can use the degree of the polynomial to determine the maximum possible number of real zeros. So if we have a third degree polynomial, it's got 3 possible real zeros. If it's a 7th degree polynomial, it's got 7 possible real zeros. So the degree, that's why it's important to understand the degree and the leading coefficient, those types of things. That degree tells us how many there can be. Now, the rational zero theorem helps us start to identify where those zeros are going to be. And it says that if P over Q is a root of the equation, then P is a factor of the constant, Q is a factor of the leading coefficient. And that'll make more sense here in just a second. But essentially what we're doing is we're going to find all the factors of the constant term, all the factors of the leading coefficient, and we're going to write them as a ratio of P over Q and all of the plus or minuses that there could be in order to help us identify potential real zeros. So when we look at this example, I have 2x cubed plus 11x squared minus 7x minus 6. So again, according to the theorem we just looked at, if I take this value, this is going to be P, and this value, this will be Q, and I'm going to list all the possible factors. So in this I have 1, 2, 3, and 6. And over here I just have 1 and 2. And you see that displayed right here. Now as I begin to list all possible real zeros or rational zeros, I just look at a ratio of P to Q. So I can just put 1 over 1, which is 1 that you see right here. So I'll just go 1 to 1, 1 to 2. And you see the 1/2 right here. And then I'll start dealing with the 2's. So I have 2 over 1 and 2 over 2. 2 over 1, 2 over 2. So this again has been duplicated. That's the same as 1, which was right here. And then we'll go to the 3, 3 over 1, 3 over 2. And then we'll go to the 6, 6 over 1, 6 over 2. And again, 6 over 2 is the same as 3 over 1, so this one's a duplicate. And then we can just condense these down. So I get plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 3, plus or minus 3/2, plus or minus 6. So these are all the possible rational zeros of this polynomial. It could intercept anywhere here. So now, in order to kind of make this a little bit simpler, if I wanted to do this completely by hand, I would then use synthetic division, and I would check all of these as roots to see which of them are divisible or can be divided into this polynomial, and then that would decompress it. We don't want to go through all that work because, see, I have 1, 2, 3, 4, 5, 6. I've got 6 of them, and they could all be the plus or minus, so that would be 12 times that I might actually have to do it to figure out which of them are the actual rational zeros. So the next step here is we're actually going to take these values, and we're going to use a calculator. And right now, all that we really need to do is we'll plug this function into the calculator, and we're going to identify, let me pull one up here. We're going to use the maximum possible in order to help us identify the domain restrictions. So let me enter this in. So I have 2x cubed plus 11x minus 7x minus 6. So I'm going to take that. And now I'm going to go to my window. Slide back down here a little bit. And again, because the greatest possible rational zeros was at -6 to +6, I'm just going to go ahead and set this to -6 because I know there's nothing that's going to intercept below that or further to the left. And I'll set it to +6. And then we'll go ahead and we'll graph this. Let me double check that, and it looks like I did miss. This should be an x squared. There we go. And we'll look at it again. And there we go. So I've got a picture very similar to this. I see it looks like it comes through right at 6. And I can go ahead and verify these on the table. And I do have one there at -6. So that is one of my zeros or my roots. It looks like I also have something that happens right here. I see the sign change between the positive to the negative, and I see another one at 1. So we're going to use the calculator to help us here. And we know that we saw 1 right here at x equals -6, 1 right here at x equals 1, and then there's 1 that appears to be somewhere in between. Well, if you go back up to your list of possible values, the only one that even falls between -1 and 0 is 1/2, -1/2. So that must be it. And then we'll just go ahead and write these out. So we have, if these are the zeros, then the factors are of the opposite sign. So an x plus 6, x plus 1/2, x minus 1. And then the 2 here gets factored out as well, because what you actually get when you decompress this is you will get 2x minus 2. So we can factor the 2 out of this and pull it out. But that's all we're going to be doing with these right now. We're using that P over Q, the factors of the constant over the factors of the leading coefficient, to help us identify the possible roots, and then we're going to use the calculator to aid us in finding where they're at. Let's take a look at another one. So let's look at all real zeros of a polynomial. This will be the rational and the irrational roots. Let's take a look. So here is my polynomial. Let me put this one in the calculator. Go back to y equals x to the 4th. Let me just clear it. We'll start fresh. X to the 4th minus 15x squared minus 10x plus 24. So there's my polynomial. So now the first thing we're going to do is we're going to identify P and Q. Q's the 1 right here. So that goes right here, the only factor. 24's got a whole bunch. And you'll see them here. 1, 2, 3, 4, 6, 8, 12, 24. So these are all possibilities. And then again, we just set them as a ratio of P to Q. So this, luckily, since Q is just 1, it makes it a little easier. So I just have 1 over 1, 2 over 1, 3 over 1, 4 over 1, and so forth. So we get plus or minus all of these factors. And you see those listed right here. So these are all the potential rational zeros. So what we're going to do now is we're going to go ahead and look at this on the calculator. And in reality, I should set this to a -24 and a positive 24. To make sure that I'm getting a picture that includes all of them. And we'll graph it. And I see they are much closer in. This would be about 12, so we're somewhere in here, probably like 8 or 6. Let's go ahead and change our window. Let's go to -8 and positive 8. I know that it certainly looked closer than 12. I'm going to go ahead and make it 8 just to make sure. And I could have moved further in. But I see 1, 2, 3, and 4. Now, since this is a 4th degree polynomial, I know that there are 4 roots, whether they are complex or rational. What I see is I see 1, 2, 3, 4. So I know that all of them end up being real zeros, or it has 4 real roots. So I know that there are no complex roots in this polynomial, which helps me. And then I can easily find these on the calculator. It looks like there is one at -3, -2, at 1, and at 4. So again, I see these right here at 1, 2, 3. That's -3, -2, 1, 4. So my roots are my zeros. So then my factors, +3, +2, -1, -4. Again, because when I sub in here, if this is a factor, I know that the value of x that will make this 0, and then anything multiplied by this 0 will equal 0, is a -3. The value of this that makes this quantity a 0 is -2, a +1, a +4. That's why the signs are reversed. The root of the 0 is where it intercepts x, and the factor is going to be the opposite sign. Okay, let's take a look at this value. So again, I see a fourth degree polynomial. I'm going to go ahead and put this in the calculator. So I know by virtue of the fact that it's a fourth degree that there are 4 possible real roots. Minus 8x squared plus 15x plus 4. And we'll go ahead and again identify. Let's take a look at how this looks on a graph. And I see that, again, there are 1, 2, 3, 4. There are 4 actual real zeros here. So there's no complex. And again, we'll identify this is P, this is Q. So I'll list my values of P, factors of 4, 1, 2, and 4. I'll list my factors of Q, 1, 2, and 4. And then I'll list all the possible all these rational. No, real would be the appropriate term. And where are all the real zeros? Well, they are a ratio of P to Q. So I have 1 over 1, 1 over 2, 1 over 4. Then I have 2 over 1, 2 over 2, 2 over 4. And then 4 over 1, 4 over 2, 4 over 4. So these are all the possible. Now there's several duplicates here. This one just condenses to 1. And then I have 1/2, 1/4. 2 over 1 is 2. 2 over 2 is 1. 2 over 4 is still 1/2. 4 over 1 is 4. 4 over 2 is 2, which is already here, and 4 over 4 is 1. So these are the possibilities. Then each of these are plus or minus. You can list them in ascending order, but it's really not necessary. I just go based on P over Q and make sure that I kind of ultimately distribute it to each value here so I don't miss any. So these are all the potential roots. So I'm going to go ahead and condense the screen a little bit. I know that the maximum is a plus or minus 4, so I'm going to change my window here. Change this to a minus 4 and to a plus 4. We'll go back and look at my graph. Okay, and there appears to be one right here at -1, +1, +4. Let's go verify those using the table. And there we go, -1, 1, 4. And then we also see that one of them occurs right here somewhere between 0 and -1. And it looks to be much closer to 0. So based on my possible real zeros, I would guess that that's probably a -1/4. So let's go ahead, and here's where we're going to be going with this. We can take these ones that I can clearly identify, we can decompress this polynomial, and we'll go ahead and then factor out the remaining. So let's take a look at what that entails. So if I take the ones that I see right here, I see, let's see, x equals -1, +1, and 4. So these appear to be 4 exact, and I verified those using the table. So I'm going to take a couple of these. I'm going to work with this 0 right here. So one of the factors is x minus 1. So what I'm going to do is I'm going to take this factor, and I'm going to use synthetic division. So I'm just going to go ahead and take the 0 here of 1. I put that in my box. I write down my leading coefficient, and then of the third squared, first degree, and the constant. Don't have to put the plus signs. Draw my line. We'll use a little synthetic division in order to decompress this. I drop the first term. 1 times 4 is 4. Combined with the -15 makes a -11. 1 times -11 is -11. -8, -11 is -19. 1 and -19 is -19, makes a -4. 1 times -4 is -4, makes it 0. So I see indeed this is a factor or a root of the polynomial. So now I've decompressed this, so I'm going to go ahead and rewrite it. So this now becomes, I'll just drop it down again, change colors here, 4, this would be then an x cubed minus 11x squared minus 19x minus 4. So I'll just drop these same values down. I'm going to take another one of these zeros. So I'm going to take the negative one here, and I'm going to use synthetic division to decompress it further. So I drop my first term times the negative 4 combined times the negative 1 combined times the negative 1. Again, I see that this has zeroed out, so I know it's a factor. So we already verified that negative 1 was a 0 of the function, and we've gone ahead and decompressed this a little bit further. So now what I know is that this was a 4th degree when I started. It represented a 3rd degree at this point, so now we're at a 2nd degree. 4x squared minus 15x minus 4. So now I'm going to take this quantity, and I'm going to go ahead and factor it out. So I got 4x squared minus 15x minus 4. So I'm going to go ahead and make my little x. I'll put 4 times negative 4 on the top, middle term in the bottom. 16 makes a 15. So 16 has factors of 1 and 16, 4 and 4, 2 and 8. I'm going to pair those at 1 and 15. Okay, so 1 and 16. In order to multiply to a negative and add to a negative 15, it must be a negative 16. So then I will make my box. Getting a little tight on space here, and we'll say this is 4x squared minus 4. This is 1x. This is negative 16x. And then we factor out the greatest common factor. So in this case, I would pull out an x. And here I would have a minus 4. Right here I would have a 4x and a, looks like a 1. So I get, let's see, x minus 4 times 4x plus 1. So let me clean this up just a little bit here and get a little bit more space. What we've found then is I had 2 of my factors originally up here. I had, it looks like, x minus 4. Actually, just found that one here. So the ones I used were x minus 1 and x plus 1. So those were 2 factors of my polynomial, and then that was multiplied. I'm trying to find space on this without deleting everything. Let's see. We will make one. There we go. Gain a little space right here. Okay, so I used x minus 1 and x plus 1 here as my first 2 factors. Those were easily found on the calculator once I knew the possible real zeros that were part of this polynomial. And then what we did is I went ahead and used synthetic division to ultimately remove those out as factors of the polynomial, which decompressed it to a 3rd degree and then down to a 2nd degree. Once I got to the 2nd degree, I used factoring in order to find my remaining 2, which are x minus 4. And then the final one here you'll see is 4x plus 1. So again, when you go ahead and minus 1 divided by 4, you get 1/4. So the actual factor or 0 here is at the negative 1/4. So it's x plus 1/4, and then that is multiplied by 4. You can put that out the front. At the end, it doesn't really matter. But 4x times 4, excuse me, 4 times x is 4x. 1/4 times 4 is 1. So it's the exact same thing as this, but we've gone ahead and simplified it down to show the actual factor. So it's very easily to see the root. And I would be quite content if you just left it as 4x plus 1 as well. That is fine. But sometimes that's difficult to derive when you see this as the root here. Okay? So that's the full process, taking P over Q, using them as the ratios in order to find the real zeros, and then using synthetic division to remove the ones that you can see until you get down to a quadratic, where then you can use one of your means quadratic formula, completing the square, or factoring in order to find the actual solution. So let's take a look at one more here. We'll go through the full steps again. Okay, so let's take a look at this. This is a fifth-degree polynomial, and I'm going to identify all the real roots, or all rational roots. So we have P, and then the leading coefficient here with 1, which is Q. So what we're going to do is we're going to find all the factors here. So I have P and Q, and factors of 42. There's a lot, so we'll say 1, 2 goes in there, 3 goes in there, 4 goes in there, 6, 7, 14, 21, 42. Now, if you have larger numbers that have a lot of factors, one way to go about finding these is to take your calculator, and we'll go to y equals. We'll just plug that value in there, 42, and then we divide it by x. Then we're going to use our table as a list, and we're going to go down and we'll see 1 and 42, 2 and 21, 3 and 14, 6 and 7, and then they're just repeating. So there's all my factors. And then because Q, the leading coefficient here, is just a 1, that makes it pretty easy. So I have potentials of plus or minus 1, plus or minus 2, 3, 4, 6, and then so forth. All of these up here. So now again, in order to try and limit these, because I don't want to check all those using synthetic division, I'm going to go ahead and graph it. So I have x raised to the 5th minus 6 x to the 4th minus 6 x to the 3rd minus 4x squared minus 27x plus 42. And we'll go ahead and graph that. And I certainly see 3 real roots. There could be more. What I should have done was probably set my window. Since I have a potential at 42, I should go negative 42 to 42 to make sure that I see everything. They may have been outside the viewable range of the window there, and the standard's just 10 to 10. And still it looks like there's just 3. So we're going to go ahead and zoom this back in. It was within 10, so I'm going to go ahead and set these down to like negative 7 and 7. There's one of them, looks like negative 2, one of them at 1, and one of them at, it looks like 7. So I have zeros or roots at, and we can again can always verify those by going to our calculator and looking for the zeros. There's 1 at 7, 1 at 1, and 1 at negative 2. So now if we want to go ahead and find all of the factors for this, what we're going to do is we're going to use the synthetic division again. I'm going to take these, and I'm going to put the first one up here. I'm just going to say negative 2. And then I'm going to write down all the coefficients. 1, negative 6, negative 6, negative 4, negative 27, and 42. Make sure all this stays on the screen here. Okay, so now I'll just drop this, and I have a 1 times negative 2 combined times negative 2 combined equals a positive 48 combined, and I get the 0 as the remainder. So again, remember your remainder theorem says if I get this 0, then this must be a root. So that's your factor theorem. And then I've actually compress this polynomial, and I now have 1x to the 4th minus 8x cubed plus 10x minus 24 plus 21. Sorry, this should be a 4th, 3rd, 2nd minus 24x plus 21. So we're going to do the same thing. I'm just going to change colors. I'm going to do it with the 1. And then we'll drop this down again. 1 times 1, negative 8 and 1, times 1, times 1, times 1. And again, it factors out. I have another 0. So now I've removed another degree from this. I'm going to do the final one here with the 7. Drop the first term. 7 times 1. So now what I'm left with is I have 1x squared, 0x's plus 3. So I'm going to go ahead and bring that back over here. Clean this up a little bit. So I know this has factors of and then 2 more because it's a 5th degree. So now I'm going to go ahead and take this final quadratic. I have 1x squared plus 0x plus 3. Now when I look at this, it doesn't appear to be factorable. This is not a perfect square. This is not a perfect square factor. So I'm going to use the quadratic formula. Negative b is a 0 in this case, plus or minus the radical or square root of b squared minus 4 times a times c all over 2a. Then we just begin some simplifying. So I get plus or minus. This would be negative 4 times 1 times 3. So that'd be a negative 12 all over 2. Negative 12 can be simplified a little further. So it's plus or minus. We're going to go ahead and pull out the negative. So I got radical negative 1, radical 4 times radical 3 all over 2. Then when this reduces, plus or minus, this is going to be I. This will be 2, and this will be square root 3. So I have 2i radical 3 all over 2. The 2's are going to cancel, and I get plus or minus I radical 3. So as I write the remaining 2 factors here, I have x plus I radical 3 and x minus I radical 3. And these would be all the factors of that polynomial. So I have 3 real roots, 2 complex. And let's look at the final example here. Find all of the real zeros. I see it's a 3rd degree, so there's potentially 3. Identify p, the constant, and q, the coefficient. So p is just 1. Q is also 1. Therefore, it must be plus or minus 1. So we're going to go ahead and set this up. This one, let's just check by hand. So I'm going to put the coefficients in here. 1, 2, negative 1. Excuse me, I forgot a placeholder. 0, because I've got cube, squared, 1st degree, and then negative 1. And I'm going to use synthetic division to check the 1. This is how you would have to do all of them if you didn't have the aid of a calculator to help you identify. Drop the first term, 1 times 1, combined, 1 times 3, combine, 1 times 3, and I get a remainder of 2. So 1 does not appear to be a 0 or a root of this polynomial. So let's check negative 1. I'm going to go ahead and drop down all these same coefficients. Drop the first term, negative 1 times 1, 2 and negative 1, negative 1. And there we see we have our 0, our root. So I have 1 there at negative 1. Now, there's only potentially one of them because p is 1 and q is 1. The only possibles would be plus or minus 1. I've already checked them both. So here is my real 0. So the other 2 are going to be complex or imaginary roots. And we can still find those. We're going to take this decompressed polynomial now, and we're going to say this is x squared plus 1 minus 1. So let's go ahead and check this. Is that factorable? Well, let's see if I had -1, +1. Nope, doesn't look like it's factorable. So what we'll do is we'll use the quadratic formula. I'm going to write it over here. So I have negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Now we'll simplify. So I get 1 squared is 1, minus 4 times 1 times -1. This would be a -4, so minus a -4, so this ends up being the radical 5 all over 2. And then we can simplify this further if we want. I could put -1/2 plus or minus radical 5. And ultimately, this doesn't simplify any further, so I'll go ahead and write this in as my remaining two factors. Clean this up. So I found that, let's see, it was x minus 1 was my 0. So my factor is the opposite sign, so x plus 1. And then I have two more. I have x minus this quantity, and if you use parentheses, it'll help keep all your signs straight. So that's minus 1/2 plus radical 5, and then x minus -1/2 minus radical 5. Apologize, I went off the screen here a little bit. Let me grab it and drag it over for you. Yeah, so if you just remember that anytime you have these roots or zeros of a polynomial, they are factors in the form commonly written x minus r. So this is a minus wherever that root might be. So if that was a -2, that flips the sign back to a +2. That's why you get that sign change. So to keep it straight here, just always says x minus, and then you put in these two quantities with the plus here and the minus there. And you could always distribute that through and condense a little bit, but this is fine. And that would be that polynomial factored with its real and its complex roots. If you have any questions, bring them tomorrow. We'll get a little bit more practice.